Hello, we're Liam,
VJ.
And Eddie.
and we're going to tell you about Maglev trains. So, first, before we can begin, we have to ask ourselves, what is a Maglev train? Maglev trains are the future of transportation. They may allow humanity to explore new heights and travel like never before. Travel more efficiently, faster, and more quicker. A maglev train is a train that utilizes magnetic levitation to propel itself along its rails. That is to say, it uses electromagnets and superconductors to generate magnetic fields for the train to float upon, instead of utilizing wheels and tracks. Now this makes the train more efficient both energy and cost-wise, since the train is not losing energy to friction between the wheels and rails. Looking from a conservation of energy perspective, more kinetic energy is conserved as not lost as heat energy due to friction, which allows the train to move faster than traditional trains. There's also less maintenance involved, since there is no friction to wear down and degrade the components of the train. Furthermore, maglev trains are more environmentally friendly, since they do not burn fossil fuels to propel themselves. They run entirely upon electricity.
Now, how exactly do maglev trains work? Maglev trains essentially use superconductors and electromagnetism on the underside of the train and on the tracks, and use the principle of opposites attract and like poles repel to move itself across the track. The repulsion pushes the train forward, and the attraction pulls the train forward. Now, there are two types of levitation that are used in maglev trains: electromagnetic suspension and electrodynamic suspension. First, let's expand upon superconductors and electromagnetism. Electromagnets are magnets which emit magnetic fields from electricity flowing through a wire. Traditionally, copper wires are used. Essentially, the magnetic field radiates perpendicularly from the direction of the current, kind of like angular momentum and the direction of rotation. The stronger the voltage, the stronger the magnetic field, and the more coils are made using the wire, the stronger the magnetic field. However, the more resistance there is, the weaker the magnetic field. This is where superconductors come in. Superconductors are extremely powerful electromagnets that have zero electrical resistance. This allows for superconductors to be very effective and conserve a lot of energy. In turn, using these in maglev trains makes the conservation of energy that much better, which allows for maglev trains to move at much higher speeds and more effectively.
Electromagnetic suspension, commonly referred to as EMS, incorporates the repulsive and attractive forces of electromagnets to induce levitation. Attractive magnetic forces are used to lift the maglev off of the rail, as can be seen in the diagram on the left. The green stator magnet on the underside of the rail attracts the red electromagnet on the train, thus exerting a force upwards on the train as a whole. This is the force responsible for the levitation of the train and therefore elimination of friction in the system. The lateral propulsion mechanisms in maglev trains are located in the rail, where electromagnets alternate between positive and negative to attract and repulse the permanent magnets in such a way that results in forward motion. Electrodynamic suspension is slightly different than EMS in that it uses supercooled superconductive electromagnets to generate levitation. The subsequent electromagnet generated by the electric field repels the series of magnets alongside the track, which act as loops of attractive and repulsive forces on the train, which lifts it off of the rail. In order for the superconductive electromagnets to provide enough force to lift the train off of the rail, a magnetic force greater than the gravitational force on the train needs to be applied. However, once the train is at its riding height, only a magnetic force equal to the gravitational force needs to be supplied.
Here's a comparison between the two different mechanisms for levitation. First, electromagnetic suspension. Advantages of electromagnetic suspension are: it is easier to implement and install into tracks. It can levitate without having to move, and that there is reduced civilian exposure to magnetic fields. Prolonged exposure to magnetic fields can damage cell phones, laptops, and other electronic devices, and credit cards, so the reduced exposure offered by EMS is safer for civilians. However, the disadvantages for electromagnetic suspension are that it requires a complex feedback loop to remain stable, so any bugs or small problems could greatly affect the system. Its ability to remain stable at high speeds also decreases, which prevents the train from attaining high speeds, and expensive computers are also required to program and monitor the train. On the other hand, there's electrodynamic suspension. Advantages include The fact that it's stable at high speeds, it has a long lifetime, which makes it better than traditional trains, and it is safe to operate even during power outages. However, disadvantages are that it cannot levitate without moving, it is costly to install, and there's significant energy involved in cooling the magnets, as electricity generates a byproduct of heat as well, and using those electromagnets will generate a lot of heat.
Although we have seen much about the benefits of superconductors, electromagnetism, and magnetic levitation to our modern society, some of you may still be wondering what the real-world applications of these technologies are. For example, electromagnetism is used today by electric motors to generate power efficiently and by credit cards to store information in magnetized bars to facilitate commerce. In fact, even superconductors are utilized by particle accelerators to create magnetic fields, which propel atoms to near the speed of light before they are collided. This ties in to Maglev trains' ability to utilize these technologies to provide efficient and fast transportation. By utilizing magnetic levitation, Maglev trains can nearly totally eliminate money lost to friction by getting rid of energy lost to friction between the train and the rails and significantly reducing maintenance costs by not having any direct contact with the rails. Railgun-like configurations wherein electromagnets are arranged in rows and utilized to propel objects through the fields they generate are being experimented with by many government organizations today. This technology has already been pioneered by the American Navy in experimental weapons, which could deliver ordnance much more efficiently and to greater effect than contemporary weapon systems. In addition, this railgun technology has been researched by NASA as a means to propel spacecraft beyond the atmosphere and into space, negating the cost and pollution generated by chemical propellants currently used by modern spacecraft to escape our atmosphere. This shows that magnetic levitation and its related technologies have a place not only in modern society, but could have a multitude of impactful applications in our future as well.
So let's have an overview. Maglev trains are efficient due to conserving energy better, fast, as friction is not present, and environmentally friendly, as it does not burn fossil fuels to propel itself. There are two types of levitation: electromagnetic suspension and electrodynamic suspension. Electromagnets facilitate movement of the train, opposites attract, and like poles repel. Electromagnets are used in credit card scanners, electromagnetic cranes, particle accelerators, motors, and etc. Magnetic levitation can also be applied in aerospace engineering as a launching mechanism for spaceship.
Well, there you have it, folks. Everything you did and didn't want to know about electromagnetism and trains that utilize that magic to float above their rails. If you have any further questions, please don't hesitate to ask Eddie or VJ or go read a book. Have a great day.